clouds. But that star is now visible. The reason, of course, is that the moon, as the eclipse proceeds, becomes dimmer and dimmer. And so across the sky, stars that were not visible in the bright light of the full moon are now coming out.
And what we're seeing now in our live images is exactly what you're seeing from your own backyard. We are seeing, I don't know, I guess about a third of the moon has gone just jet black. Now, I'd like to invite in Mr. Bob Berman, SLU's astronomer. Bob, have you got any questions for Professor Ferris?
Questions? No, I would just say that I'm a longtime admirer, and Timothy Ferris is certainly one of the great astronomy writers of the last century.
Okay.
Thank you, Bob.
Mutual Admiration Society. Let's start it here. Professor Ferris, thank you very much for joining us tonight. I know that you're running off because you want to capture the total phases of the eclipse tonight. So thank you very much for joining us. And we must have you back at SLU to talk about some of your other work. So thank you very much for joining us tonight.
Thank you. It's been a pleasure. Enjoy the eclipse.
Well, enjoy the...
As it does so. Now, the moon is 1/4 of a million miles away, so that means the moon is well within our shadow's ability to touch it. Our shadow can hit no other celestial object. Only the moon can venture into Earth's shadow of all the natural objects. Well, of course, there is the occasional near-Earth asteroid, near-Earth object that can do it, but of the normal celestial objects, it's only the moon. And yet, at the moon's distance, the Earth's shadow is shrunken. It's not 8,000 miles wide, but closer to 5,000 miles wide. So as we look at the moon right now, we're seeing the curved edge, the bright edge of the moon. That obviously has a very strong radius of curvature. But now look at the curvature of Earth, and you'll see the curvature of Earth is closer to being a straight line. It's not a straight line. It's got a little bit of a curve to it, but much less of a curve than the moon has. So right there and then is proof that A, Earth is round, because only a ball always throws a round shadow. If Earth were a dish or a disk, a flat plate, we would throw a round shadow only when we were aligned perpendicularly to the sun, which would be rare. Other times we might throw a straight line shadow. Only a ball always throws a round shadow. So we know that we're a sphere. And unfortunately for you Flat Earth Society members who may be watching the eclipse, you're going to have to resign your membership, because there is the proof. The second thing we're looking at is proof that Earth is bigger than the moon, because we can see from the shadow that the moon is going into that Earth has got to be a bigger ball than the moon. And the third thing we can actually infer from this, and this is without any particular knowledge, is approximately the motion of the moon. If the moon takes a month to circle around us, it's actually 27.32166 days, about a month. Let's round it to 4 weeks, and it takes an hour to go into the
special promotion. And we're going to talk about this specifically a little bit later about what you can do. But the special promotion is, if you join SLU today to control the big telescopes, you will get a pair of free binoculars. So this is a limited time offer. We can't hold it open. It's going to be while stocks last, but all you got to do is go to the SLU.com. It's a line that continues off, and I always see that. Do you know what causes that?
Well, again, you're seeing the is rotating, of course. At that latitude, it's probably rotating at about 600 miles per hour in the direction of the shadow. So Earth is casting its own shadow on itself, and you can only see it clearly at that time of the evening. But I'm seeing what you're talking about from here. I'm a little distance from the screen.
Okay.
More than I'd like to be, but yes, I can see the mountaintop's shadow. Yes, beautiful.
We'll pick that up. I mean, this is a totally unique view, and this, by the way, is provided courtesy of our partners in the Canary Islands. It's the Institute of Astrophysics in the Canary Islands. They manage the world-class observatory site where SLU's telescopes based. And we have a half-meter telescope, and we have a high-magnification planetary telescope, and a small wider field telescope as well. And those are the telescopes that SLU members control every clear night. And because we're above at least a classroom of 2, but actually I know we have got people from all around the world tonight, but I love the fact that some parents have kept their kids up late. If there was ever a reason to stay up late, then
yes.
a
And this is
lunar
it. And gentlemen, if I can just interrupt for just 15 seconds,
Absolutely,
I love listening to Michael as well. So it's a mutual admiration society, I assure you. But just at this moment, this is it. Totality is about to start, and just look at this strange, weird moon as the tiny bit of sunlight is hitting the right side of the moon. We're only a few minutes down from totality, and just fantastic, isn't it?
It is. It's absolutely glorious. And Matt Francis there at Prescott Observatory, you are doing a wonderful job. Now, between Bob Berman, SLU astronomer, and Michael Narlock, SLU educator, we've got some questions that I'm going to fire at you. Now, this is not a buzzer round, all right? The first question, I think, goes to Michael. And this is it. This is from Barefoot Sommelier. And the question is, does atmospheric pollution deepen the reddening of the moon?
Absolutely. The more particles basically you have in our atmosphere, the darker the shadow is going to be, the more reddish it's going to be. I recall some years ago there was an eruption of, I think, Mount Pinatubo, and it resulted in all the particles that it shot into the atmosphere resulted in a very dark, almost eerie blood red moon. So yeah, the more particles you put into the atmosphere, the redder our shadow is going to be, and the more ominous the total eclipsed moon is going to look.
That's right, and it also matters about your altitude. Now, strangely, there's a very close to the SLU Observatory in the Canary Islands. They're kind of adjacent. They're our neighbours there. Is what's called the Earthshine Observatory, and what that observatory does is it's kind of taking images like this. It's the unsunlit portion of the moon, and what they do is they measure the brightness of that, and what they're measuring really is the clarity of the atmosphere. So there's an awful lot going on at these observatories that people don't really know about. Now, Bob, I got another question here for you. I'm sorry to ask again. Anyone, do you by chance remember what they said was going to show on August something 2017, first one in 30 years? That's a solar eclipse, isn't it, in North America?
Yes, that's the first time in 38 years that the moon's shadow itself will land on Earth. A total solar eclipse. We've had annular eclipses, but not a solar one. And this will be coast to coast from the Pacific Northwest all the way to the Carolinas, and quite an event that we're looking forward to now. A total solar eclipse makes people weep. It makes animals go crazy. And it's a life-changing event. This is really wonderful.
Now sorry, Bob, a solar eclipse, unlike a lunar eclipse, which is kind of visible from one half
now, even though and it's very interesting that they're in the same part of the sky. In my entire life, in our lives, we have never seen a total eclipse of the moon on the same night that Mars came closest to Earth, that Mars was at its very brightest, in this case the very brightest in 6 years, at the same time that the moon turned its coppery red because of an eclipse. So this is a astonishing rare occurrence. Mars is at its closest to Earth, essentially, or within a few days of its opposition, meaning that, to answer this caller's question, viewer's question, the Sun, the Earth, and Mars are in a straight line when Mars is closest. Okay? An eclipse moon can only happen at full moon, when the moon is opposite the Sun. So Mars comes closest to us when it's had to be. If Mars is at its brightest and the moon is in eclipse, they needed to be near each other. But the exact time of closest to each other physically in the sky, that happened 12 hours ago before the eclipse began.
What a night we've had here, Bob, at SLU. We've had the live show. We had Rob Manning from the Jet Propulsion Laboratory. We were talking about Mars being its closest to Earth in the last 6 years. And now we're watching these fabulous live images of the lunar eclipse. You're sitting in the Prescott Observatory with Observatory Director Matt Francis generating these beautiful, beautiful images. Now, we are kind of changing our scheduled program here, Bob. I'll probably get in lots of trouble, but we're deciding with our producer tonight that we can't give you a recorded interview while we're getting these fantastic color images of the moon. So we're going to kind of put that back a little bit. We're going to invite Jeff in maybe over the next half an hour, and it's just fabulous. But what you're looking down on is all of that mucky, horrible, turbulent air which is trapped down below you, and that's exactly what you want to be above for telescopes. And that's why we call the Canary Islands Observatory a world-class observatory site. There are 3 sites in the world which are this good, and one's in Chile, one's in Hawaii, and one's in the Canary Islands. And the Canary Islands houses some of the biggest of Europe's telescopes. It actually has a 10-meter telescope, which is absolutely enormous. It also has some of the biggest and best solar telescopes as well. I've got a question for you here, Jeff. You
Sure.
might be able to answer. This is from Yasmin Garcia, and she says, does the weather affect how red the moon appears? Now, is that one for you to answer?
The weather, well, the weather doesn't, but interestingly enough, we would not see the moon look red if the Earth didn't have an atmosphere, because what you're seeing is the sunlight going through the Earth's atmosphere. And as Bob mentioned earlier, it is the light that we see in sunrises and sunsets that then passes through the atmosphere. Most of the colors, when sunlight takes a long trip through the atmosphere, most of the colors are scattered out, and the reds are what's left. So what you're looking at now is the moon illuminated with this light from the sun that has been bent and passed through the Earth's atmosphere. And that's why on a night like tonight with a lunar eclipse, you're looking at this reddish color on the moon. If the Earth had no atmosphere, we wouldn't see that. In fact, if you see a shadow on the moon, the shadow on the moon is very hard. You're either all in sunlight or all in darkness, whereas a shadow on the Earth, because of our atmosphere, is much more soft. It's much more filtered and scattered by the atmosphere. So we don't have the same kind of hard shadow here on the Earth that you would see if you were looking at a shadow cast on the International Space Station or cast on the surface of moon where there is no atmosphere.
Great answer, Jeff. Great answer. We're watching a live image now. This is from the Prescott Observatory. Matt Francis, director there, has been providing these stunning images for all of us who either...
And so, you know, Paul, I'm back here.
Oh, you're back, Bob. Well, that's great timing. I was just saying, we're just about 10 minutes away now from what is called U3. This is where the moon is coming out of the umbra, this darker shadow. And we can actually see the effect of that quite a lot. Bob, I'm going to come straight to you with a couple of questions because it's a
a half moon. It could fool somebody into thinking that it was just an ordinary moon on a non-eclipse night. So enjoy this period of time now. Also enjoy it because the distinct redness, it was so beautiful, that coppery, deep orangey color that we still see is going to now fade and be replaced by the appearance of a black shadow. We now know that it's really a red shadow. But as the exposure must change to compensate for the brilliant sunlight that will be increasingly striking the moon's surface, we will have to underexpose the red part and that will appear black. And the same is true if you're watching it directly. Your eye will underexpose the red part and start to make it appear black. So we're going to say goodbye to the colorful part of the eclipse very soon.
But we're going to remain with you for the entire eclipse. You're not getting rid of us that quickly. Now,